question involves Newton's law of cooling. That was the exact same one that was on the bonus on the quiz. We have a formula where the capital T is the temperature after time has passed. And the T sub 0 is the initial starting temperature. The T sub R is the room temperature. E is the natural...
Is this real?
I don't know about it. So please do not talk out in the hall. Go right out this door. Stay together. Okay, guys. We were about plug number 2. Yeah.
Also, like to say the time up to 5:16, so the recording that.
It like jumps time. Like there's so much time that I actually remember to pause it. So I did leave it recording during the terrible fire drill one. So I left it recording during lunch, like on a block day. Whoops. All right, so we are going to see how long it will take for a 112-degree cup of coffee to cool to a temperature of 85 degrees when the surrounding temperature is 56, and the cooling rate of coffee is 0.034. So we know the cooling rate. We know the original temperature, we know the new temperature after time has passed, we just don't know the time. Let's plug everything in. The new temperature is going to be 85 degrees. Original temperature is 112 minus room temperature 56. Multiply that by E to the negative.
Please.
T to the negative, the cooling rate is 0.034. We don't know the time, and then plus the room temperature. 56. So we're going to solve the equation. We can get T by itself, which we do first. Subtract 56. Yes, on 2 different places, right? Subtract 56 and simplify that parentheses. So we're going to have 29 equals 56 times e to the negative 0.034 t. So we got rid of the 56 and subtracted inside the parentheses. Now, we got to get t by itself. We want to take the outermost thing that's being done and get rid of it. Which is divide by 56. Now, 29 divided by 56 does not go evenly, and I'm not going to use a decimal until the very end, so I'm just going to leave it as 29 over 56. Just leave it like that. What's the next thing we need to get rid of? Get rid of the e by using its inverse, ln. So my next step is we're going to ln, we're going to log both sides. ln of 29 over 56 and ln of e to the negative 0.034 t. So that cancels the ln of the, and the e. Divide by negative 0.034. And this is where you finally type something in your calculator. Go ahead and type that in and see that you get the exact same answer that I got. By typing it in your calculator, we've got different calculators out there. So try typing it in yours.
Sound not right?
Yep, you got it.
What is it?
You got it. All right, 19.35 what?
What?
Minutes.
I got
I'm going to tell around to the nearest minute.
Oh yeah, it did, but then I changed it on my.
I got 193.
You're at 193, so you didn't have the right answer. Did you put in the right decimal? Sorry, I changed it on here for it to stay because of the.
I put 2 zeros.
You typed it wrong.
I guess.
I probably do. Are there none in that thing? I have some.
Allergies are awful.
You should get a tissue instead of shoving it back up.
Yeah, I don't know where they are. Oh, they're all gone. Sweet.
But if nobody throws that away, I didn't know it was out.
Exactly. See, it's like God. It's an easy way to put it.
Okay, next question. You move a baked potato from a 400-degree oven and place it on the counter in your 67-degree kitchen. After 20 minutes, you measure the temperature of the potato and it is 128 degrees. What will the temperature of the potato be after 26 minutes? So we're going to use Newton's law of cooling, but something is not given to us. In Newton's law of cooling, we don't know the cooling rate of a potato. I know what it is for coffee, but I don't know for potatoes. So we're going to have to use the first piece of information, the 20 minutes. After 20 minutes, the potato is 128 degrees. If you use that information to find out the cooling rate first, then we'll go back and we'll use that to find the temperature after 26 minutes. So I'm going to start by saying that the potato is 128 degrees after 20 minutes. So what is the initial temperature of the potato? 400. You pull it out of the oven and it matches the oven's measurement until it cools. The room temperature is 67. Multiplied by e to the negative, I don't know the rate, but in this situation, 20 minutes. And then plus the room temperature, 67. So the first thing we're going to do is find the cooling rate. So we're going to subtract 67 in the parentheses and then to both sides. And then we're going to divide by 333. And then we have to get to the exponent. The only way to get rid of the exponent is getting rid of the
That's roll.
ln. So we're going to ln both sides. So once we divide both sides by negative 20, we're going to have to use our calculator at that point. You're going to get a cooling rate. And you can write down a decimal, but we're not going to use that decimal because we don't want to round it yet. I'm going to do this on my calculator. I have it. I'll show you. So I'm doing 61 divided by 333, and then that divided by negative 20. So you should get a cooling rate of 0.084863 something. Does everybody get that? So we're going to use that answer. And we're going to redo the problem. This time it's for 26 minutes. So I don't know the temperature. This is still 333. This is still e to the negative. Instead of negative 20r, it's negative 26r plus 67. So the same equation. We don't know the new temperature and it is a different time. But we do know the rate. So what I'm going to do is I'm going to type into my calculator. I'm going to type in my calculator using the answer button. And use that previous answer. I'll show you. I'm going to do it on my calculator. That's what I'm going to do so I don't have to retype in and it's an accurate answer. So I'm typing in 333 multiplied by e to the negative 26 times answer plus 67. Now, depending on what calculator you have, you should definitely try this. If you have my exact calculator, it's easy to copy what I have, but not everybody has my same calculator. So I would try that. You should get 103.66. You try it on yours?
Degrees.
Yep.
So like, what if it were Celsius with the same formula? Like, I don't know if that's.
Probably not. I would have to think about that for a moment. Nobody asked that yet. But if it were Celsius, you can convert it. All right, good. Next one. So the next section is exponential models. So if you aren't given the formula, but you know information, like you know a growth rate or you know a decay rate, you can write the equation. So the growth model is y equals a parenthesis 1 plus r to the t. What do you think t stands for? Time. R, what do you think R stands for? Rate. But here's the thing. R is always the percent divided by 100. It is the rate in decimal form. It is not the rate as a percent. Use the rate as a percent, you're going to get it wrong. So rate in decimal. Anybody know what A is? Okay. It is the initial amount. It is your starting amount, your initial amount. And then Y would be the amount after time has passed. The second formula is exactly the same except for it's minus. It would be for decay or for an amount that's going down. So a material of 490 grams decays at a rate of 0.94% per year. How much material will be left after 9 years? We're going to use the decay formula. We do not know how much material is left, but we do know we're starting with 490. We're going to do 1. Is it going to be plus or minus? Minus because it's decay, right? So we're going to do minus, and then what number? So you have to take that 0.94% and divide it by 100 to find the decimal that goes there. And then that is going to be to the time, which they tell us 9. And then you can type that in your calculator to get it.
Like, and as far as time goes, if this were like after 9 months, would it make sense?
If it were after 9 months, you'd have to put time would be 3/4.
So it's based on years?
Yeah, it's based on years.
Okay.
Mm-hmm. Well, let me go back and say that again. Okay. So the percent, the decay rate is per year.
Okay,
So that tells me that my T is in years. So if I said how much after 9 months, I would have to put 3/4 of a year.
But if it were like.
But if it said 0.94% per month,
Then 9 months.
then 9 months, you'd be able to say 9.
Okay.
So they'd have to match. Good question, because that's actually going to come up at your homework. All right, did we get it? What did you get? 450.07 what? am
Right.
so. What did you say?
One.
Oh, it doesn't go number one. Oh yeah, it didn't really say what to round to, but we're doing hundredths unless it says otherwise. Okay.
I was changing your trash.
That's fine.
Oh, okay.
In a lab, 370 cells are present at the beginning of the experiment. During the first 9 hours, the number of cells increased by 10% each hour. Write an exponential model giving the number of cells y present t hours after starting the experiment. So this says, this sentence says we're going to find an answer. It's just going to be a model. It's just going to be an equation. There's a second part that says now estimate the time when the cells, number of cells is 600. So there's actually two parts to this question. So first thing is writing an exponential model. So we're going to write y equals, what's our initial amount?
Wait, that's not like in the paragraph.
370.
What's not in the paragraph?
The sentence photo on it, is it? I don't know. I think that's more words than we have.
I zoomed it in and went like this, so it's just bigger.
Okay.
Okay, 370, then we're going to multiply that by, is this going to be a 1 plus or a 1 minus situation? It's a plus that says increase. We're going to add 10%, so I'm going to add what? So 1.1 to the, so, right, these hours. What?
Yeah, like why,
Did I simplify it? 1 plus 0.1 is 1.1.
oh, because that's, okay.
I just add them together. But we're on the time. So this says write an exponential model for y cells and t hours. That's telling us that it's not 9, it's telling us for any t. So it's just t. Yeah. So the 9 is kind of a distractor in there that everybody wants to put 9 for that spot. It's a distractor. It's telling you this is what the pattern was for the first 9 hours. Now write it for everything. So this is the first answer. The second part now says, now let's put in 600 and see what time that would be. So what I'm going to do to both sides to solve for t. Divide by 370. I'm not going to find a decimal. I'm just going to divide it, maybe reduce a little bit. You don't have to reduce. I did. And I get 60 over 37 equals 1.1 t. Now there was a question just like this, not exactly, but kind of like this on the last part of your quiz last week. Someone did not know how to do this question. So we need to know how we can get t by itself. So there's different methods. You could do log base 1.1 to both sides. Or you could do log base 10 to both sides. I'm going to do log base 10 for all of them. But you could do log base 1.1 both sides. Feel free to do it that way. Make sure you get the same answer that I get. I'm going to do log base 10 both sides. You could also do ln to both sides, just so you know. That one works too. Try it. Wherever I write log, you write ln. It works. Okay, so from here, I now have log of 60 over 37 equals, this is going to be t multiplied by log 1.1. Because if I have an exponent, I could expand it and put it in front. And then from there, I'm going to solve for t by getting rid of log 1.1. How am I going to get rid of that? Divide both sides. So my calculator, I will be typing in log of 60 over 37 divided by log 1.1. Type it in. See that you get the same answer I got. Round it to 100. I just had more decimals.
Yeah.
You should get 5.07 hours. Okay, next one. Some of you working ahead. Excellent. This next one has two parts to it. The first part is we are putting $1,200 into the account that earns 3% interest, compounded annually. How long will it take your investment to reach $2,000? And the second part, how long before your investment doubles? Okay. Before we work it out, if you've already worked it out, please don't yell at the answer. But before we work it out, do you have any like ideas of how long it's gonna take $1,200 to change into $2,000? 4?
Say yes.
4? Any guesses? I like to know what you think.
I feel like I wouldn't do this with logs. I feel like I do this. I just like,
We're gonna do it slow.
I know, but I would do it the logical way.
Okay, what's your logical way?
Take 3%, multiply by 1,200, add that, take 3% of that, and keep going until you get to 2,000.
But what if it doesn't exactly equal 2,000?
I mean, it doesn't have to be exactly. It says 2 each. It doesn't say 2 each exactly 2,000. It can be 2,000.
Right, well, we're gonna be to the nearest 100, accurate.
We'll change that.
Right. So that is, I mean, that's how you would approach it for sure, if you didn't know how to do logarithms. So we know how to do logarithms, we will be able to solve it. So who else has guesses? Who hasn't done it yet? I want to hear your guesses. Say something. Come on. What's your guess, Linda?
Probably like 30 years.
30 years.
It's gonna be a lot of years.
Give me a number.
3% is close.
Yeah. 50 years.
50. What do you think yours is? Either
20.
20. Did you already do it, Abby?
No.
What's your guess?
It's
I don't
30
know.
since the old.
Give me a number.
30.
30 years. You do it already?
I said it.
What do you think?
I was gonna say, I just.
Confident.
10. 10. You already did it. Abby, you already did it. What's your guess? You already did it. All right, so we're going to want this to equal 2,000, and we're starting at 1,200. This is an increase of 3%, so it's going to be 1.03. We're taking 1 plus 0.03, yes?
If the price is right, schools, whoever close.
Without going over. Just start doing it. All right, then what we're going to do is we're going to divide both sides by 1,200. I'm going to divide by 1,200, and I don't know what that is, but I know it's 20 over 12, whatever that is, or 10 over 6, or 5 over 3. Okay. Doesn't really matter. You can leave it at 2,000 over 1,200 if you want. Then we get the point where we have to get rid of the base of 1.03, so I'm going to do log for both sides. I'm going to log both sides. That's going to give me log of 20 over 12 equals t multiplied by log of 1.03. Remember, the t can go in front when it's an exponent on the log. And we can divide both sides by log 1.03. So, yeah. If you had started investing when you were born, you would now have $2,000, right? Is it 0.28? Is that what it is? So about a little over 17 years. 17.28 years it would take. It's the rate. But it's also, this is only $1,200. If you put $1 million in for 17 years at 3%, it's going to be a lot more than $1,200. Okay, the next question is, how long is it going to take to double? So I'm going to start it out by, how am I going to start that out? 2,400 equals 1,200 times 1.03 to the t. So it's like the same, I just had to figure out what double 1,200 is. Then we're going to divide by 1,200. And this is something I really want you to pay attention to just to save yourself some time. When I divide by 1,200, I get 2 equals 1.03 to the t. And in fact, it does not matter what my original starting money was. If I double it and then I divide by that number, I'm always going to get 2 here, always. So I really didn't even need to do this first step. I could go straight to there if I want to. Okay, then from there, we're going to log both sides. Log 2 equals t multiplied by log 1.03, and then divide by log 1.03. $23.45. So if you put $1 million in, how long would it take you to get to $2 million? 23.45 years.
Always.
With 3%. Yeah, because right here, it's just doubling. It doesn't matter if there's 1,200 and 2,400 or 1 million and 2 million. When you divide that first number, it's going to be 2 right here. So it's going to take the same amount of time to double the money, no matter how much money there was in there. All right, number 6, you purchase a new car for $27,000. And the car will depreciate 30% annually. This is what they were talking about in the parking lot when they went out there. Evan, did you hear? Who was talking about it? Blake was talking about it. You didn't hear?
I did.
What?
We're looking at that
I
page.
said how my husband won't let me get a new car.
Oh.
Why?
This is why. Yes. Well, because when you purchase a new car, it like depreciates a lot in that first year. So this is an average of 30% annually. After how many years will your car be worth 10% of what you paid for it? So let's start out. What did we pay for it? $27,000. Is this a 1 plus or a 1 minus situation? This is a minus, and it's 30%. After that time, how much will I have left? Or how much will it be worth? Okay, you're saying 2,700 because how did you get that number? You multiplied 10% of 27,000, right? So we got 2,700 is equal to 27,000 multiplied by 0.7 to the t. And then we're going to divide both sides by 27,000. And what happens on the left side when I divide by 27,000? What do I get here? 10%. So just like the doubling thing, if I want to know when it's 10%, if I put that number right here with the rate, it will tell me the answer.
Is that
Because I'm going
7 or 10?
that looks like 7, doesn't it?
I know you did know.
Okay, so what are we going to do to get t by itself? Log both sides. We're going to have log 10% equals log 0.7. We multiply the t in front. Divide both sides by log 0.7. And we get 6.46 years. Does that seem right? That a $27,000 vehicle will only be worth $2,700 in 6.5 years.
Yep.
That seems right to you?
Maybe you want to do like 10 years.
Hey, but it's the depreciation thing. Which is why, what I was saying earlier, why my husband won't let me have a new car. Oh, he- Does he get a new one? He gets a company car.
Oh.
So,
That's still.
he gets a new car, I guess I tried the old one. Not cool. But,
I mean, he technically gets his car for free though, right?
right.
Okay, well, that makes
You buy
sense.
your car and whether he wants it.
But that's not really what marriage is.
I mean, why would they spend money on something else? Because if he gets a free car, she just gets the car, you just,
I know, it just,
I mean, it makes
Is it-
sense.
it doesn't matter. When you have children and they destroy your car, you
Yeah,
That's
I was
not-
gonna say, you have kids, don't you?
Buy a used car.
If you got a new car, maybe.
Yeah, but he'll buy you some. But okay, I have the assignment is a worksheet and I still have it recording because I want to go over one question together. And as soon as you get it, read number 4. Number 4. There's 3 of them. So give one to one of those ladies.
Which you get all his old used cars.
Well, I had a car before I used it. I have that one and then I have his old, his company car.
At least you got your
You
kids.
still have one that before you do him?
Yeah, my other car is,
How old is that car?
10 years,
Oh.
11 years.
Okay.
Well, at least your kids get a car.
But I'm telling you, if anybody's looking for a car,
What is it?
70-some thousand miles, Honda Elantra. It's only has like 70-some thousand miles on it, 11 years old. It's got another 100,000 miles on it.
So like the car I had, like it was an actual granny car, and so
Yeah.
she didn't like use it much.
Yeah.
Like,
All right, let's look at number 4 together. That one, I didn't do an example like it, so I'm just gonna help you set it up. Population of rabbits quadruples every 2 years. If the initial number of rabbits was 25, how long will it take the population to reach 700? What number am I gonna write first? 700. Equals, what's my initial amount? 25. So this is the reason why we're going over this one together. There's not a percent. Do we know if it's increase or decrease?
Increase.
Definitely increase. It quadruples.
4.
So this is going to be a 4. Okay? So it's actually, if you were talking about percent, it would be a 300% increase. That would be like a 1 plus 3 in there to give us a 4. But it doesn't say that, it just says quadruples. Now, the other tricky part is it quadruples every 2 years. And then how long will it take the population to reach 700? So if we're going to find T is years, but this populates every 2 years, we're going to do T divided by 2 for our exponent.
So like if it like tripled every 2 years, it would be 25 times 3.
but that would be
Wait, every how many years though?
Every 2 years, so it would be
Right.
25 times 3.
Right. Or if it tripled every 5 years, we would have a 3 there and a divide by 5 up there. Yeah.
what would that like triple be in terms of percent?
It would be plus, it would be 1 plus 2, 3 is 1 plus 2, so it'd be 200%. Like it increases by 200%, which makes it a total of 300%. 3 times. But it's increasing by 200%. So anyway, that's the only one like that one.